Hello everybody. We welcome everyone to our presentation for SAS Global Forum 2021. We are Team Job Seekers from Oklahoma State University presenting you our analysis on Are you qualified? Assessing a candidate's chance for a specific job application. Let me introduce the team. We have Frank Yeboah, who is the analyst for this project but in spirit a big brother, followed by Nikhil Gunti, who is a techie geek but actually a data scientist for the project. And myself, Maruti Shankar Nanduri, quirkily feel that I'm a jack of none, but looks like I did some things with the analysis. And finally, we have Monish Vallamkonda, who was the timekeeper and also performed the duties of a project manager, making sure we follow all the deadlines correctly. The presentation will address the business problems, key objectives, data description and preparation, the analysis performed, followed by the future scope and recommendation. Our main business problem is based on the employee hiring process that can be cumbersome and tedious with increasing number of job seekers entering the market. Primarily, the issue is with longer wait times for responses to job applications that each candidate goes through after applying for a job. Secondly, the process is further complicated with the lack of transparency by putting the candidates in dark and not letting them know their feedback, particularly the rejected candidates. The Bureau of Labor Statistics has created a taxonomy of occupational groups called the Standard Occupational Classification, SOC, which contains all the occupational categories and the corresponding jobs under each category. Candidates can refer to the SOC for generic job descriptions for each occupation. We observed that the occupational categories in SOC formed are based on text-driven description and has less quantitative backing. This actually poses a risk of non-representative SOC groups, which will be addressed in our analysis. The problems mentioned in the previous slide are addressed by first validating the existing SOC structure created by the BLS by performing the clustering using numeric ratings to various occupational descriptors by O-Net survey to check any anomalies in the current SOC system. This is followed by creating a use case to assess a candidate's fitness for a job application and then subsequently suggest any suitable job skills accordingly if they are lacking. The Occupational Information Network O-Net program is the primary source of occupational information for the US, which contains hundreds of occupation-specific descriptors on almost 1,000 occupations that cover the US economy, which will be partly used in our analysis. The O-Net database is developed through a continuing data collection program by surveying job incumbents using standard questionnaires, and based on the responses to the surveys, ratings for each occupational descriptor are assigned. All this information is compiled in 37 tables in the O-Net database that encompasses details related to education, knowledge, skills, abilities, interests, work activities, work values, etc. surrounding each occupation. Based on the standard occupational classification, the O-Net includes 23 occupational groups like production, healthcare, management, business, finance, legal, construction, and so on. These groups consist of 974 distinct occupations like chief executives, auditors, accountants, legislators, BI analysts, mathematicians, sales managers, and so on. Each occupation is characterized by the incumbent ratings for 256 occupational descriptors like active learning, active listening, critical thinking, English language, finger dexterity, time management, written expression, etc. that are key in performing work duties. This is an example of how an O-Net data table looks like for describing the abilities required for occupations. The element name is the occupational descriptor used, while the importance and scale represent the rating given to the descriptor and the corresponding scale on which the rating is measured. The labor condition application data for H-1B visa is used for building content-based and collaborative filtering recommendation systems, where we used user ID, SOC code, SOC title, job title, minimum education, major field of study, and skills. This is also supported by O-Net occupation description data in the O-Net database that gives short description for each occupation in the SOC. This is an example of datasets LCA and O-Net occupation description, which are combined and used in building the recommendation engines. Initially, the raw Excel files are converted to SAS data tables using SAS macros, after which the data preparation step begins. In this, the first step, we join 8 tables consisting of descriptors related to abilities, interests, knowledge, skills, work activities, work styles, work values, respectively. Since the descriptors in each of these tables are rated on different scales, like some on a scale of 1 to 10 and some on a scale of 1 to 5 or 1 to 100, we observed a need to standardize those ratings on a uniform scale of 1 to 10. After standardization, we pivoted the element column to have descriptors as columns and occupations as rows, with standardized ratings as the data. 2 columns with missing values greater than 60% are exempted from the analysis, which makes the final table with 974 rows and 254 columns on which the new clusters will be built. This is a quick look on how the final data looks like, where each row contains the occupation with the corresponding SOC code, SOC title and descriptors as columns, along with the major group in which each occupation belongs to. We have performed a basic exploratory analysis to check the frequency of the occupational groups, where production occupations have the highest number of distinct jobs with 112, followed by 86 in healthcare practitioners and technical occupations. Legal occupations group has the least number of distinct occupations with just 8. As a data science enthusiasts, I am interested to know about the occupations in computer and mathematical occupations, which has 33 jobs, including software developers, statisticians, data scientists, database administrators, and so on. We have used agglomerative hierarchical clustering to evaluate the current SOC system based on the ratings given to descriptors that are inherently organized into a hierarchical structure, which is based on text-driven job descriptions. There are 25 new occupational clusters formed using squared Euclidean distance, analogous to the 23 major groups in the current SOC. The frequency distribution of the clusters reveal that cluster 5 has the highest number of clusters with about 97 occupations in it. Clusters 17 and 4 take the last spot in this context with 2 occupations, which are followed by 11 and 12 with 3 occupations. We have identified 65 descriptor columns that are important in forming the clusters, where this slide lists the top 10 of those. Active listening is noticed to be the most important descriptor in differentiating the clusters, followed by written expression and comprehension. Let us profile 2 of the significant clusters in our analysis. The first one is cluster 5, which contains 10% of the total occupations, mainly including computer, mathematical, architecture, engineering, life, physical, and social science jobs. Key characteristics in this cluster are observed to be oral expression, which has a score of 7.3, while written expression is 5.4, and intuitively, one of the most important and flagship descriptor, that is complex problem solving, has surprisingly a lower value of 5.2 in this cluster on a scale of 10. Cluster 17 has just 2 occupations, dancers and fitness trainers and aerobic instructors that are grouped together. Major frontline descriptors in this group are gross body equilibrium with a score of 6.3, while innovation is 7.8 and cooperation has a rating of 8.3 on a scale of 10. After examining the new occupational clusters in comparison with the current SOC system, multiple differences are observed. Methane or landfill gas collection system operators and methane or landfill gas collection system technicians quantitatively contain similar ratings for job descriptors in our analysis, due to which they are grouped together in cluster 20. But they are grouped in separate categories in a current SOC structure, with one in management and the other in production. Same is the case for water resource specialists and water resource engineers, who are together in cluster 5 with similar ratings, but are in different groups in SOC due to minor changes in the job descriptions, with water resource specialists being in management, while water engineers in architecture and engineering groups. Another important occupation is computer and information systems managers and information technology project managers, that might intuitively fall under the same cluster, which is cluster 7, that is validated by our analysis, are observed to be in subroad groups, one in management, and the other in computer and mathematical occupation in the SOC. These changes iterate that there is a need to take domain and numeric importance of each skill or ability into consideration while classifying the occupation, in contrast to the generic job description. This is a use case of assessing a candidate's fitness to a given job based on sample data of an applicant. The example here is the candidate applying for a statistician job. The average descriptor ratings are numbers collected from the final data prepared in an analysis for the occupation. The applicant ratings are a sample collected from an applicant before resume screening. The data represents that the candidate has good numbers on processing information, system analysis, analytical thinking, and all others that are marked in green, indicating these parameters are above average for the candidate. While the data shows that the applicant need to focus on analyzing data, mathematical reasoning, and programming that are marked in red, indicating a below average score. On similar lines, an applicant for HR manager is screened to notice a need for improvement in guiding, directing, and motivating and staffing organizational unit parameters, while others in green are fine. And now we have the interesting and final portion of our analysis on recommendation engines for job applicants, which will be driven by my colleague Nikhil Gunti.
Thank you, Maruti. We built a job recommendation engine based out of algorithms, content-based filtering, and collaborative filtering. For these recommendation engines, we used LCA dataset for the H-1B visa applications. The main variables included are ONET job title, ONET SOC code, H-1B employee's major level of study, and employee's education level, and job description from ONET data descriptions table. For content-based filtering method, the job title and its corresponding job descriptions were combined into a single column, and a TF-IDF matrix or term frequency inverse document frequency matrix was generated out of it. A linear kernel function is applied on top of it to create similarities between job titles. We now generated cosine similarity matrix so that for any given ONET job title, the engine recommends the top 10 similar job titles. These results are explained using an example. Consider a job applicant, Emma, who has applied to job 1 as shown on the slide. Now we knew that job 1 and job 2 are similar in their job descriptions. Based on the content-based filtering method, job 2 can be recommended to Emma as an alternate opportunity based on similar job requirements or descriptions. This can be illustrated with a better real-world use case. For any job title, similarity matrix is generated with corresponding all other 973 job titles, and then top 10 job titles are retrieved based on the highest similarity score. Here for the job title, graphic designer, according to content-based filtering method, these are the top 10 recommendations. So job titles like art directors, desktop publishers, multimedia artists and animators can be recommended to a user who applied for a job graphic designer. These are the corresponding similarity scores for the job title with respect to graphic designer. Similarly, for the job title chemist, these are the top 10 alternate job titles that can be recommended to a user, and we also have similarity scores corresponding to these job titles with respect to applied job title chemist. In the collaborative filtering approach, the recommendation engine built is focused on using the employee's highest education level and the major field of study. A matrix factorization algorithm is used to create k nearest neighbors for each candidate. From this, top 10 jobs that other applicants with the same educational background and major field of study apply to are known and can be recommended to others. So let us illustrate with a simple example. Emma, who has applied to jobs 1, 2 and 3. We also have other job applicant Jules who shares similar educational background with Emma, implying that they both have same educational background and same major field of study. Emma applied to job 1, 2 and 3, whereas Jules applied to job 1 and 2. Since they both share the similar educational profiles, job 3 can be recommended to Jules so that he could apply as well. A candidate who applied for a statistician job with a user ID 7 and 86, these are the top 10 similar users who share similar educational backgrounds and major field of study. So we could recommend these top 10 job titles for the user who applied for the job title statistician. So based on the collaborative filtering approach, these are the top 10 similar users who applied to corresponding job titles. So these could be recommended to a user 7986. So based on our analysis for this business problem, our recommendations include developing occupational groups based on quantitative importance of descriptors. The Bureau of Labor Statistics can also use the clustering algorithm results in this research to re-evaluate their SOC grouping criteria and produce a more representative occupational grouping based on the ratings of skills and abilities. Hiring companies can also use the clustering algorithm approach proposed in this analysis to assess the skills and other descriptor ratings of applicants prior to a first resume review. This provides quick screening of the candidate by confirming the applicant's profile with the important skills for a given position and reducing human error during the resume reviews. Say, for example, a particular job applicant applies to a job and he or she does not have to wait for 6 weeks to get the feedback from a recruiter. Now, since the recruiter job is resume screening job is easy, he can get the feedback in less amount of time. Building a hybrid recommendation engine by combining both content-based and collaborative filtering algorithms will definitely help job seekers in finding suitable jobs based on their skills and improve the chance of landing a job. A particular job applicant who applied for a data analyst role, for example, would get recommendations for other suitable roles like data scientist, business intelligence engineer, or a machine learning engineer, etc., using hybrid recommendation engine method. This concludes our presentation. We would like to thank the SAS Symposium team for giving us the opportunity to present our analysis.